Hello. In this video, we're going to go ahead and find all values of x where the following piecewise defined function is discontinuous. So if we look at this function, it's f of x equals 5x minus 4 when x is less than 0, x squared when 0 is less than or equal to x is less than or equal to 3, and x plus 6 when x is greater than 3. Now here's the thing. When we have all of these definitions as polynomials, polynomials are continuous everywhere. So if we have that, anywhere where these are defined, that is in fact continuous in those regions. It's only at these boundaries where we might have some discontinuities. So if you notice, we have 0 and 3 as the possible points of discontinuity. Now remember, we have three different things that we need for it to be continuous at those points. The first one is that the function value exists. The second one is that the limit as x approaches that value exists. And the third one is that the limit is equal to the function value. So let's see how these work. At x equaling 0, let's first look at whether the function value is defined. So I want to find f of 0. Notice if I plug these in here into these test regions, 0 is less than 0. Is that true? Well, no, it's not. 0 less than or equal to 0. Is 0 less than or equal to 0? Yes, it is, because it's equal to 0, so it is less than or equal to 0. So this is what we use for the definition. So here we just type in 0 squared, which of course gives us 0. So f of 0 is equal to 0. Good. So that means that for this one, the function value exists. Good. Now for the next one, let's look at the limits. The limit as x goes to 0 from the left of the function value would be the same thing as the limit as x goes to 0 from technically just x goes to 0 of. Now, if we're to the left of 0, that means we're less than 0, which means that we're in this region. Another way of looking at that is use a test number of -1. Is -1 less than 0? Yes, it is. So plug this in for f of x. That's going to give us of 5x minus 4. And then just plug in 0 there. 5 times 0 is 0, minus 4 is -4. So it tells me the limit as x approaches 0 from the left is -4. Now, let's look at the limit as x approaches 0 from the right. Well, that would be the limit as x approaches 0 of the function. Now, if it's 0 from the right, think of 0.1. So 0.1 less than 0? No, that doesn't work. But 0 less than or equal to 0.1? Yes, it is. So we plug in the x squared there. So of x squared, and then plug in the 0 for the x squared. That gives us 0. But notice that the limit from the left-hand side is -4. The limit from the right-hand side is 0. Those are opposite, or they're not opposites. They're just not the same value. Therefore, the limit as x approaches 0 of the function does not exist. Which means, of course, for this one, the second condition fails, which means x equaling 0 will be discontinuous. Good. Now let's look at x equaling 3. The first thing we look for is f of 3. Now notice that 3 less than or equal to 3 is true, which means that x squared is where this is defined at x equaling 3. Which means we would think of this as 3 squared. And 3 squared is 9. Good. Next, let's look at the limits. We have the limit as x goes to 3 from the left-hand side of the function. But then we need to just replace the f of x with something. Well, if we're to the left of 3, we're in this region, or think of it as 2. Is 2 less than or equal to 3? And yes, it is. So x squared is what we replace that with. So x squared there, and then simplify. What is x squared? Well, what is 3 squared? 3 squared is 9. Good. Next, let's look at the limit as x goes to 3 from the right-hand side. And that's going to give me the limit as x goes to 3 from the right-hand, or just 3, period. Now, if we're to the right of 3, where x is greater than 3, in other words, think of 4. Is 4 greater than 3? And the answer is yes, which means we'll use this one here, x plus 6, and then plug in 3. 3 plus 6 is 9. Therefore, since the limit from the left is 9 and the limit from the right is 9, that means that the limit exists and it is in fact 9. Excellent. That means that for this one, this works. There we go. That was the previous one, there we go. Now for the last one, we're going to look at these two things. We have the limit as x approaches 3 of f of x equals 9, f of 3 equals 9. Therefore, the limit as x approaches 3 of f of x is in fact f of 3, because they're both 9. So as a result, that checks it out, and therefore this is in fact continuous at x equals 3. Awesome. Alrighty. Well, that's what we did in this so far. I do want to go ahead and look at this in the calculator so that you can see how you can type this in and kind of look at the calculator to help you as well. Alrighty, I will see you there. Okay, welcome back to the calculator. Let me go ahead and clear that so it's clear what we're doing. Go into y equals, clear anything that's there. And in y1, we're just going to type in the function. Now this is a piecewise defined function, so start with a parentheses and then type in the first definition. That first definition was 5x minus 4. And then close your parentheses. Then open a new parentheses and type in the condition. And the condition was x is less than 0. But we don't want to start with the x, so go to second math to go to conditions here. X is less than is the second condition. And we want to say less than 0 here. Close parentheses. Good. So this is that first line in the piecewise defined function. Now plus, and then parentheses, and then the second definition, which is x squared. Close parentheses. Open a new parentheses and type in the condition. Now it's 0 is less than or equal to x is less than or equal to 3. So I'm going to start with a 0, and then go to condition, which is second math, and then 0 less than or equal to x less than or equal to 3. So less than or equal to is right here, less than or equal to is right here. Now if any of these were different, if it was less than or equal to and less than, I would use 7. Or if it was less than and less than or equal to, I would use 8. Or if they were both less than, I would use 6. So just make sure that you're matching up these less than or equal to's or less thans and all that type of nonsense there. So I'm going to click on 5 for this one. And notice that we have 0 less than or equal to x, and x is less than or equal to, in this case, 3. Close parentheses. Plus a new parentheses, this third definition, which is x plus 6, close parentheses, and then parentheses, the last condition, so second math, go to conditions, and it's x is greater than 3, so that would be the fourth condition. And then 3. Close parentheses, and that's it. I'm going to go ahead and do zoom 6. And there you go. This is, in fact, the function. It's a little bit harder to see. I'm going to go ahead and make the maximum window closer to 15 here. There we go. So notice that we're going up here. And then from the left-hand side, we're actually approaching -4 here. And it's not actually going to reach -4 up here, so it's actually going to be discontinuous at x equals 0. At x equals 3, though, this x squared is equaling this line as well, so therefore they're matching each other, which means that this is in fact continuous there. Now it's looking like there's some weirdness happening down here, so let's zoom back in there. Let's go back to the standard window. What is that? -4 to -5, so let's make that negative, say, -6 to -3. And minimum, say, -1 to 1. Okay, no, it's working. It just looks like it's doing weird stuff there. I do want to zoom in a little bit. So we'll say -0.1 to 0.1. And it's at 4 that we're looking at. So -4.1 and -3.9. Graph. Yeah, maybe that's just my imagination. Anyway, sorry. Oops. Zoom 6. There we go. There we go. Fun times. All right. Well, I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.